We left off on the decreasing interval. We decided it was from negative infinity on the x-axis again, remember, because that's where my focal point is, or my eye should be. So from negative infinity, my graph is going to decrease all the way until it hits the minimum value of 9, -6. So on the x-axis, it's going to stop decreasing when it hits at 9. So that's why my decreasing interval is parentheses, negative infinity, comma 9 with a bracket. Now what's neat about this type of graph is you can see when you look at the increasing and decreasing intervals, they are basically flipped around. My 9 or my x value of that minimum point is on the left-hand side for increasing and on the right-hand side for decreasing. And then my infinities, whether they're positive or negative, are kind of opposite as well. Finally, or the last key feature that we need to identify in this graph is the range. So again, as it says up here, this is where you need to focus your eyes on the y-axis. To determine my range, then, that means my eyes have to look from negative infinity, which is down here, all the way up to positive infinity, which is up here towards the top of my graph paper. So if I'm starting kind of like on an elevator and I'm starting at negative infinity, I'm going to start working my way up, and I notice that there's nothing being graphed down in this space. And there's nothing being graphed until this point of 9, -6. So my starting point for my range is when y equals -6. Then as I continue up along the y-axis with my pen, I can see then with my graph how it's going to go higher and higher and higher, and due to the arrows and the continuous nature of my graph, it's going to go on forever. So that means when I'm starting at -6 on the y-axis and I continue to go higher and higher and higher, it's going to eventually reach infinity. So for my range then, I'm going to be starting with a bracket at -6, and it's going to continue on, or my range will continue on until it reaches positive infinity with parentheses. Therefore, we have all key features identified for this function graph. So we are done identifying the key features. Next, we're going to go ahead and talk about not a function, or the key features of a graph that is not a function. Again, as we can see from what I have graphed here, it's not a function because if I were to draw vertical or imaginary vertical dotted lines, I would hit my graph once at the top here and then a second time on the bottom. So this x value, which is 2, has 2 different coordinate points or 2 outputs, which makes it not a function. Therefore, I want you to go ahead and pause the video at this time so you can go ahead and graph this not function graph, as well as exactly what I had you do before by having the coordinate points, those key features listed on the left, and then the interval notation key features listed on the right. So go ahead and pause me so you can do that. All right, now that we're back, we're going to go ahead and identify the key features of this graph. So let's go ahead and start with the coordinate points, and let's look for our x-intercept or intercepts. So as I look above here and grab my green highlighter, I can see that this graph runs through or touches my x-axis at one particular point, and that is right here. And when I look at that point, that has an x value of 5 and a y value of 0. So for my x-intercept, my coordinate point is 5, 0. For my y-intercept or y-intercepts then, I need to look at my y-axis and see where my graph hits that. So I'm going to take my purple highlighter, and I can clearly see that my y-intercept or my graph hits here on my y-axis. And again, that is when y is 5, and I see that x is 0. So for my y-intercept, I have 1 at 0, 5. For my maximum and minimum then, that's a little bit different with this graph, or this not a function graph, because if I can see, or if you can see here, I can clearly see that there is no true maximum or no true minimum, meaning I can tell that from the y-axis here, my graph goes down and continues on forever this way. So there's no lowest point on my graph. And if I were to start at my y-intercept again up here and I continue on the graph up in this direction, it continues on forever. So there's no true point or no highest point here. So this is an example where I have no true max and no true minimum. So again, my 4 key features that involve coordinate points are complete, and I can go ahead and move on into the interval notation. So let's go ahead and come up with our interval notation for the key features of domain, increasing, and decreasing. So before we do that, let's go ahead and label our axes, where on the x-axis, this goes to negative infinity, this goes to positive infinity on the right, and then for my y-axis, I start down at negative infinity, and I will travel up towards positive infinity always. So for my domain, if I start out in negative infinity land and with my pen I continue towards the right on the number line, I can see that there is nothing graphed on this part of my graph paper. And nothing of my graph begins until I hit 0 on the x-axis. So that means my domain will start at 0. And as I continue in the positive direction, I can see that my arrows continue on forever. So my domain is going to be 0 to positive infinity. So 0 with a bracket to positive infinity with parentheses. My increasing then is going to be looking at my graph and seeing where my graph goes up. So I'm going to grab my green highlighter, and I can see that my graph goes in an upward direction at the top here. So I'm going to circle the top and write the word increasing. When I focus my eyes in on that and continue to look on the x-axis, I can see that my increasing interval that I have to write down here happens when x is 0 and continues on to positive infinity as well. So just like in my domain, my increasing interval is going to be bracket 0, infinity with parentheses. Likewise, then, my decreasing interval, which I'm going to grab my purple highlighter, my decreasing interval, anywhere the graph is going in a downward direction, so I'm going to label this decreasing, also happens to start when x is 0. And as I move my pen along the x-axis, my decreasing part of my graph is going to continue on forever and ever this way. So my pen is going to eventually reach positive infinity as well. So what's interesting about this graph is the domain, increasing, and decreasing intervals are all the same, meaning they start with a bracket at 0 and go towards positive infinity. Finally then, in order to come up with my range, I need to look at my y-axis. So again, like an elevator, we start way at the bottom, we start at negative infinity. And what I can see is when I start at negative infinity, my graph continues on forever down in this direction. So it's going to decrease forever and ever and ever until it hits negative infinity. So my range has to start at negative infinity. And as I travel up the elevator on the y-axis, I can see that my graph is going to then continue as it switches into an increasing part of my graph. It's also going to continue on and on and on forever as I move up on the y-axis to positive infinity. Therefore, my range spans from negative infinity with a parenthesis to positive infinity with a parenthesis. So again, another example of a graph, this time not a function, where I can still identify these 8 key features, and keeping in mind what we talked about on the summary note sheet about what key features are coordinate points and what key features we write as interval notation. So now that we're done with lesson 1.2b in our summary notes, I'm going to have you go back to the summary notes page that you had to print, and we're going to start covering lesson 1.2c.